Hello students, I hope all of you are fine. And today I am going to explain the first chapter of physics, that is reflection and refraction of light, which is the first chapter of physics of class 10 textbook. What is light? It is an invisible energy which causes in us sensation of sight. That means it is a form of energy, just like other forms of energy like sound, or you can say electricity. It is also a form of energy. Here we are using one specific term, that is invisible energy. Suppose in a room one burning candle is there and no other source of light is there, and near it you kept one book and you are standing here. Now light after striking the book will reflect and then only you can see. Now between the book and the candle you cannot see any light. Since we do not see light in the space between the source and the object, that's why we use the term invisible energy. That means light itself cannot be seen, but when light strikes any object and bounces back or reflects back, then only objects are visible. I hope the definition of light is clear. Now what are the sources of light? As all of you know, the primary source of light is sun, and rather it is the ultimate source of energy for the Earth's surface. Sun actually, it is a huge ball of hydrogen gas. One of the isotopes of hydrogen, that is called deuterium, is present inside sun. And those deuterium, or you can say even hydrogen, fuses by thermonuclear process, and during the nuclear reaction it liberates huge amount of light and heat, and we receive that energy every day, and this is the main source of light for the Earth's surface. When we say objects, objects can be luminous or non-luminous. What do we mean by luminous objects? Objects which give out light energy on their own, like sun, stars, burning candle. That means any object which has its own light, they are called luminous objects. As you can see, one burning candle is there, and burning candle is emitting its own light, so it is a luminous object. Non-luminous objects. What are non-luminous objects? Objects which do not give light energy of their own but reflect the light falling in them. Example, book, pen, wood. Now as you can see, one pen is there. This pen does not give light energy of its own, but it is reflecting the light that is falling in this pen from the tube. This type of objects which just reflect the light falling in them, those objects are called non-luminous objects. This book, pen, wood, whatever we see around us, most of the objects are non-luminous, and sun, stars, burning candle, firefly, all these are called luminous objects. I hope luminous objects and non-luminous objects, these 2 points are clear. Let me discuss the next thing, that is the optical medium. What are optical medium? Anything, material or non-material, through which light energy passes wholly or partially. Example, vacuum, air, glass. That means any material or non-material through which light can pass. Light cannot pass through wood, so that means wood is not optical medium. Light cannot pass through metals, so metals are not optical medium. I can consider water, glass, plastic. These type of objects are called optical medium. Here you can see through this lens light can pass, so this is an optical medium. Through this paper, butter paper, light can pass partially, so this is also optical medium. Through this transparent sheet also light can pass totally. In vacuum, no particles are present. That means it is not a material, but still through vacuum light can pass. So vacuum, air, glass, transparent sheets, all these are optical medium. These optical mediums can be of 2 types. One is called transparent, and another is called translucent. Transparent means the optical medium which allows most of the light energy to pass through them. As you can see through this glass, light energy can easily pass. So this type of materials are called transparent. You can see this type of transparent plastic sheets are there. Through them also light can pass, so they are called transparent. There are some material which partially allows the light energy to pass through them. As you can see, this type of butter paper, through them light partially passes, so this type of papers are called translucent. And this type of glasses through which light energy can pass almost totally, they are called transparent. I hope transparent and translucent, these 2 points are now clear. Now what do you mean by opaque objects? Opaque means bodies which do not allow light energy to pass through them are called opaque objects. Say suppose this type of paper. Now through this paper, can you see what is written here? If I cover it, now I cannot see anything. That means this type of materials are called opaque objects. You can consider wood, stones, metals, all these are opaque because through them light energy cannot pass. I hope transparent, translucent and opaque, these 3 terms are now clear. Now next point that I want to discuss is ray. What do you mean by ray? Ray means the path along which light energy travels in a given direction, or you can say straight line drawn in the direction of propagation of light is called ray of light. Suppose this is a burning candle and the energy is passing from candle in this particular direction. The energy is originated from this point, so we have to give one arrow like this. This type of representation is called ray. So it is the path along which light energy from this burning candle travels in this specific direction. Beam of light. What is beam of light? It is the collection of adjacent rays of light. That means instead of one, if you consider multiple rays, then those collection of adjacent rays form beam of light. These beam of light can be of 3 types. First one is called parallel. When rays of light travel parallel to each other in the same direction, as you can see here 3 rays are there and all of them are moving in the same direction. So this type of rays are called parallel rays, and since it is a collection of rays, so it is called parallel beam. When we are having rays of light coming from different direction, as you can see here directions are not same and they are moving towards a particular point. As you can see here in the definition, when the rays of light coming from different directions get closer and meet at a point, so all of them are coming from different direction and ultimately moving towards a particular point, then this type of rays are called convergent rays. And since we have considered multiple rays, so we can say convergent beam. And when the rays of light are coming from a point and then travel in different direction, they are coming, you can see here 3 rays that originated from the same point but they are moving in different direction, then this type of beam is called divergent beam. I hope parallel, convergent and divergent beam of light are now clear. What is the nature of light? In some cases light behaves like particles and in some cases it behaves like waves. Some of the physical phenomena can be explained by considering light to be particles. Again, some of the phenomena of physics like diffraction interference can be explained by considering the wave nature of light. The particulate nature of light was put forward by Newton, and the wave theory of light, or rather wave nature of light, it was put forward by another scientist. His name was Huygens. So nowadays we consider light has dual nature. Depending upon its interaction with the matter, sometimes it behaves like a particle or like a wave. Clear? Now, what are the basic characteristics of light? When we say light, first of all, already I have explained that it is an invisible energy. It is a form of energy which cannot be seen. Second, it travels in a straight line path, which is also known as rectilinear propagation of light. That means between 2 points, light always moves in a straight line path. It produces shadows when obstructed by opaque objects. Suppose you can see here some shadows are formed. These shadows are there because this Class-10 is opaque in nature. So it produces shadows when obstructed by opaque objects. And the velocity of light in vacuum is 3 into 10 to the power 8 meters per second. Though the velocity of light is different in different media, and in vacuum it is 3 into 10 to the power 8 meters per second, and it is the maximum speed that any object in the Earth's surface can attain. The next characteristic is that the velocity of light changes while traveling from one transparent medium to another transparent medium. That means in vacuum the speed of light is 3 into 10 to the power 8 meters per second, but when light moves through glass or water or plastic or any other material like diamond, the speed of light will not remain same. It is going to reduce. And the last point, during change in velocity of light, its frequency remains same but wavelength changes. Suppose light is traveling from air to water, and when it moves from air to water, its velocity is going to change. Here it will be more and here the velocity will be less. And it is found that the frequency of light here and here, it will remain same, but the wavelength of light here and in water, it will not remain same. That's why we say its frequency remains same, but wavelength will change while going from one medium to another medium, because whenever it goes from one medium to another medium, its velocity will change. Now what is reflection of light? In simple terms, we can say bouncing back of light from the surfaces is called reflection. Definition wise, we can say when a ray or beam of light traveling through a certain medium, this is the ray of light which is traveling in a certain medium, strikes an opaque but a polished surface. So it strikes a polished surface, it bounces off the surface into the original medium. This ray of light, after striking the surface, it bounces back in the same medium. This phenomenon is called reflection of light. Whatever we see around us, everything is because of reflection of light, because light, after striking the objects, it reflects back. And when this reflected rays strikes our eyes, then only we can see those objects. Now this reflection can be of two types. One is called regular reflection, another is called irregular reflection. In case of regular reflection, when a parallel beam of light traveling through a certain medium on striking a smooth surface is reflected back in the same medium as a parallel beam. Incident rays are parallel, and after reflection, reflected rays are also parallel, then we say these are regular reflection. And when the surface is not smooth, if the rough surface is there, then you can see parallel rays are striking. Here beam is parallel, but after reflection, they are moving in different direction. That means reflected rays are not parallel. Then we use the term diffused or irregular reflection. I hope the terms regular reflection and irregular reflection, these two are clear. Now I am going to the next part, that is mirror. Now what is a mirror? A smooth and highly polished reflecting surface is called a mirror. Commonly we use this type of mirror in our home, which is highly polished. Now how it is prepared? First of all, we have to take a plain glass. Then we have to give a layer of silver, because silver is the best reflector of light. And then on top of the silver layer, just to protect the silver layer, a thin layer of red lead oxide is given. And this is how the mirrors that we use in our home are generally prepared. There are two kinds of mirror. One is called plane mirror, another is called curved mirror. In case of plane mirror, highly polished plane surface is considered. So you can see here, this type of mirrors are called plane mirror because highly polished plane surface we have considered. And whenever mirrors are prepared from highly polished curved surface, then they are called curved mirrors. You can see here, this type of mirrors are called curved mirrors. Clear? Because these surfaces are not plane. Now, when we say curved mirrors can be of two types. One is called spherical, and another is called parabolic. In case of plane mirror, we represent like this. We draw a straight line and we give this symbol. And this symbol indicates that it is a plane mirror, and this upper surface is the reflecting surface. Now if I take a sphere like cricket ball, suppose this is made of glass, and from this part, only from this part, if I make a mirror, then that type of mirror is called spherical mirror. In case of a curved mirror, if the polished part is a part of a hollow sphere, then they are called spherical mirror. This type of mirrors are called spherical mirrors. Okay, because these are part of a sphere. The curved mirror is called parabolic mirror if its surface is a part of a hollow parabolic piece of glass. So if this type of glasses are there, and if this is the reflecting surface, then they are called parabolic mirrors. And if you are having a polished part which is a part of a hollow sphere, this is the hollow sphere, only this part we have converted into a mirror, and this is the reflecting surface, then these are called spherical mirrors. A man is a mirror, and this ray of light strikes the mirror at a particular point, suppose O. Then this ray is called the incident ray, and the point where the incident ray strikes the mirror is called the point of incidence. Clear? The ray which strikes the mirror, this ray is called incident ray, and the point where the ray strikes the mirror is called the point of incidence. This incident ray, after striking the mirror at O, it bounces back. The ray which bounces off the mirror surface after reflection is called the reflected ray. So this is the incident ray, this is the reflected ray and this is the mirror, and the point where the incident ray strikes is called the point of incidence. Suppose this is the mirror and this is a line which makes an angle of 90 degree, then this line is called normal. Here this dotted line is the normal because this dotted line is making 90 degree with Mn. Now the angle between the incident ray and the normal, this angle between incident ray and normal, this angle is called the angle of incidence, and the angle between the reflected ray and the normal, this angle is called the angle of reflection. I hope the terms incident ray, reflected ray, normal, angle of incidence, angle of reflection, point of incidence, these terms are now clear. Now whenever reflection takes place, it always follows two rules or two laws. Now law number 1 is that angle of incidence is always equal to the angle of reflection. Here you can see this angle, suppose this angle is 30 degree, this also will be 30 degree. If it is 45, this also will be 45. Whether it is smooth surface or rough surface, in all the cases, angle of incidence and angle of reflection will be same. And second law is at the point of incidence, incident ray, reflected ray and normal all lie in the same plane. Suppose this is the incident ray, this is the reflected ray and this is the normal. Now these three, already I told you, this angle and this angle must be equal. And second law is that incident ray, reflected ray and normal all must be in the same plane. That means if I keep a piece of paper, all will stay paper. Okay, it's not that it will be something like this. Now what is normal incidence? When the ray strikes a plane mirror at an angle of 90 degree, then it is called normal incidence. And here after reflection, it will bounce back in the same direction. Okay, the ray will retrace its path in the opposite direction. And in this case, since there is no angle between the normal and the incident ray, so angle of incidence, angle of reflection, both will be 0. Imagine this is the incident ray and this is the normal. Now, if both of them coincide, in that case there will not be any angle. So, in case of normal incidence, angle of incidence is also 0, angle of reflection is also 0. Now, what is an image? When the rays of light diverging from a point, after reflection or diffraction, either actually meet at some point or appear to meet at some point, then that point is called the image of that object. Now let me explain the definition of image. Suppose this is the object and this is a plane mirror and these are two incident rays. In this way, millions of rays are there. It's not possible to draw all the rays. So for image formation, we generally draw only two rays. So this is one incident ray. This ray after striking the mirror will reflect following the laws of reflection. This is another ray. This ray after striking the mirror also will reflect. So these two rays are incident rays and these two rays are reflected rays. And as per the definition, when the rays after reflection or refraction actually meet at a point or appears to meet, and here these two rays, if we produce in the backward direction, it appears as if they are meeting at this point. So this is the object, this is the image. Clear? This is the object. From this object, these are the two rays. These two rays after reflection, they are going in this direction. From this position, if we view, it will appear as if the rays are coming from this point. So this point is the image of this object. Clear? And here, since the rays appears, it's not that actually rays are meeting here. Here the rays appears to come from this point. So this type of image is called virtual image. Clear? Suppose this is one mirror, this is a spherical mirror and this is the object. From this object, again thousands of rays are going in different direction. For the image formation, we need to draw two rays. Suppose this is one ray. This ray after striking, it will go this way. This is another ray. After striking the mirror, it will reflect this way. So these red ones, these are the reflected rays. And as per the definition, the point where reflected rays meet or appear to meet. So this is one reflected ray, this is another reflected ray. These two reflected rays are meeting at this point. So this is the object and this is the image. Since the rays actually meet at this point, so this type of image are called real image. Now what is lateral inversion? It is a phenomenon due to which the image of an object turns through an angle of 180 degree through vertical axis such that the right side of the object appears as left of the image and vice versa. Here you can see in this figure that here this P, suppose this is the object, and if I keep a mirror here, in the mirror you can see an image such that it would appear as if it is 9. Now this P, it rotates by an angle of 180 degree through vertical axis, because this is the axis of rotation. This line is the axis of rotation. This P I have written in this piece of paper. Now if I keep a mirror here, you can see in the mirror the image. Just see this P, it appears to be as if it is 9. So this phenomenon where the right side of the object appears to be left, this is called lateral inversion. Suppose this is the object and this is the image. If this is the case, then we say this is inverted image, where you can see it is upside down. And if this is the object and this is the image, both of them are in the same direction, we say they are erect image. Suppose MN is a mirror and AB is an object. From a, rays are going in different direction. Here we are considering two rays. One ray which is striking the mirror normally will rebound back in the same direction. Another ray which strikes the mirror at point P will reflect by following the rules of reflection. Similarly, from B, if I consider a ray which strikes the mirror normally will rebound back in the same direction. Another ray which moves towards the point Q will reflect by following the laws of reflection. Here, this is one reflected ray, this is another reflected ray, this is one reflected ray, and this is the reflected ray. These reflected rays are not meeting anywhere. Now if you produce them in the backward side, then we are going to get the image. If I produce this one and this ray in the backward direction, we are going to get this point. Suppose this point is A prime, so this point is the image of point A. Similarly, if I produce this ray and this ray, this one and this one in the backward direction, we are going to get this point. So this point is the image of point B, which can be written as B prime. So A prime is the image of A and B prime is the image of B. Similarly, from all the points of AB, similar type of reflection will take place and similar image formation will take place between A prime and B prime. So if I join these 2 points, we are going to get the virtual image. So this is the virtual image. Here this is the object, this is the image. So the characteristics of image formed by a plane mirror are: the image is virtual, image is erect, image is of the same size as that of the object, the image is laterally inverted, and distance of the object from the mirror is same as distance of the image from the mirror. So these are the characteristics of the image formed by a plane mirror.